Okay, so continuing with this chapter with dealing with exponents, today we're going to be introduced to this topic of rational exponents. And by rational exponents, we're referring to exponents that are fractions. Now, if you look at this little diagram that I wrote up here, this is extremely important to make sure that you understand. Whenever we have an exponent that's a fraction, the denominator of that exponent represents the root. The numerator represents the power. So in the previous lesson, we talked about roots, and that if I have something like 81 to the 1/2 power, it's the same as the square root of 81. Well, what if we had a problem like this? 81 to the 3/4 power. Well, there's two ways that we could go about doing this, and that's what's described in this box. Now, I'll hold off on writing anything right now, because let's talk about this for a second. We have a root and we have a power here. The denominator represents the fact that we're going to have to take the fourth root. The numerator represents the fact that we're going to have to take the third power. Now, if you think about it, when we apply a power, the number gets bigger. When we apply a root, the number gets smaller. So wouldn't it make more sense to take the root first to make this number smaller as opposed to taking and cubing it first? Because in this box, that's what this bottom one is telling you. This is the hard way to do it. What this is telling us is that we're going to take and break this apart and apply the power first and then the root. So if I had 81 to the 3/4 power, what the second way is saying is to take and cube the 81 first and then take the fourth root of it. Well, who wants to sit here, especially if you have to solve this problem without a calculator? Who wants to sit and take 81 times itself 3 times and then take the fourth root of it? That doesn't make any sense. So we're not going to use this method. This is the one that we're going to want to be familiar with. What this tells you is, again, we're going to take the rational exponent, the exponent that's a fraction, and we're going to break it apart into two pieces. The first part is the root. The second part is the power. So for this particular problem, I would take the fourth root of 81, meaning what times itself 4 times would give me 81? Well, hopefully you'll know that that's 3, because 3 times itself 4 times is 81. So taking the fourth root of 81, we get 3, and now we're going to apply the power. 3 cubed is 27. So see how easy that was to do with that without a calculator? Again, if you had to take the power first, then the root, there's no way you could do this without a calculator. So let's look at another example. Here we have 64. If you can't read this, it's 64 to the 5/6 power, meaning we're going to break this apart into the root and then the power. So this is the 6th root raised to the 5th power, because our denominator is a 6. So that tells us what the root is. The numerator is a 5, so it tells us what the power is. So it's the 6th root of 64. That's what we're going to do first. Well, think about it. We're multiplying a number by itself 6 times, and we only have a number as large as 64. That tells me it's got to be a small number here. So 2 times itself 6 times would give me 64. Well, now I have to take 2 to the 5th power, which 2 to the 5th power means 2 times itself again 5 times. Don't say 10. It's 2 times 2 times 2 times 2 times 2, which gives you 32. Now there's a couple ways you could do that. You could, again, multiply it out and say, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 would be 32. Or we can work our way backwards from 64, because remember, 2 to the 6th power is 64, so if I take and divide that by 2, going backwards 1, I would get 32. Just an option there for you. Now we want to be able to do as much of this as we can without a calculator, because on your test that's going to be the case. So let's look at this next one. We have 64 y to the 9th being raised to the 4/3 power. So what we're going to do here is we're going to simplify this by applying this 4/3 to everything in parentheses here. So it's going to be 64 to the 4/3 power y. Now we're going to multiply these. 9 is the same as 9 over 1. So when I multiply these, 9 times 4 is 36. 1 times 3 is 3. So this is the same as 36 thirds. We'll simplify. We'll come back to that part in a second. But let's start with the 64. Again, I'm going to break this up into the root and then the power. So this would be the third root raised to the fourth power. Well, 4 times itself 3 times gives me 64, because 4 times 4 is 16, and 16 times 4 gives me 64. Now I have to take 64, or take 4 to the fourth power. Well, I know 4 to the third power is 64, so I'm going to have to take 64 times 4. Well, to do that in your head, there's one way to do that. This is what I do in my head. I break it apart into 60 plus 4. And I know that, so 64 is the same as 60 plus 4. I know 4 times 60 is 240. 4 times 4 is 16. So when I add those in my head, I get 256. So that's a way we can do some mental math there. Or the other way to do it is to use the lattice method that you're taught in middle school. So here's the lattice method. 4 times 4 is 16. 4 times 6 is 24. So this would be 6. Add this diagonal up. 4 plus 1 is 5. Add that diagonal up, you get 2. So you get 256. So either way you do it, but you're going to want to know how to do this without a calculator. So again, the 64 to the 4/3 power simplifies to be 256. Now we have to go to the y. Well, the nice thing is fractional exponents work the same as fractions. If they can be reduced at all, we can do that. 36 divided by 3 is 12. So I'd write this as 256 times y to the 12th power. And that would be my answer. Let's try this next one. Oops. Okay, so with the next one, we have 27x to the 6 being raised to the 2/3 power. So I'm going to distribute that 2/3. So it's going to be 27 to the 2/3 power times x. We're going to, again, that 6 is the same as 6 over 1. So when I multiply those together, that's the same as 12/3. Now let's simplify this. Let's start with the 27 to the 2/3. That's the same as the cubed root of 27 being squared. Well, the cubed root of 27 is 3. 3 squared is 9. So the first part simplifies to be 9. Then we go to the x. 12 divided by 3 is 4, so it's going to be 9x to the 4th power. And there's your answer. Let's talk about how to solve an equation. Now, anytime we have exponents involved in an equation, first off, you want to make sure that you have the variable by itself. So let's say if I had x to the 2/3 power plus 8, let's put a 2 in front of here, equaling 12. If I had to solve this equation, I could, but the first step I need to do is subtract 8, then divide by 2, and then take care of the 2/3 as my exponent. So the key is you can't do anything with the x until you have everything else cleared out, and so you have the x isolated all by itself. So focusing on this problem now, the x is already isolated by itself. We have x to the 3/4 equals 7.2. So in order to get rid of this exponent, I have to take the reciprocal of it. The reciprocal, let me write this over here. The reciprocal of 3/4 is 4/3. So 3/4 times 4/3 is 1 whole, so I'm left with just x equaling. And then on my calculator, I'm going to do this. I'm going to take 7.2 to the 4/3 power. Now, a note about typing this in on your calculator. I don't have a regular scientific calculator to bring up on the screen, so you'll just have to, if you have one on your own, you can look at it. But if you take 7.2, we're going to do 4/3, our exponent. So we're going to look for that caret button. Now, the nice thing is, if you're using a CAS calculator, as soon as you type the caret button in on your screen, you're going to see 7.2 and then this little text box, and everything that you type will be written as an exponent. So for you, this, what I'm talking about, doesn't apply. But if you have a scientific calculator, and if we just typed in our exponent button, so our caret button, and then typed in 4 divided by 3, here's what the calculator is going to do. It's going to take 7.2 to the 4th power and divide that answer by 3, because that's what you're telling it. What we need to do on our calculators, if you have a scientific calculator, is when you type in the caret button, and we're going to have a fraction that's an exponent, we need to put this part in parentheses. So we're telling our calculator that this whole thing is a part of our exponent. So now when I do that on my calculator, and I take 7.2 to the 4/3 power, I'm going to get 13.9 is my answer. Okay, so why don't you guys take a second and try to solve this next example on your own. Just want you to pause the video and hit play when you're ready to check your answer. So let's see how you did. So we would first take and apply our exponent here. Is the reciprocal of 5/4 is 4/5. So 5/4 times 4/5 gets my x by itself. But we have to apply that 4/5 to the 6.8 as well. So when I do that on your calculator, you're going to get 6.8. Don't forget to put the 4/5 in parentheses. And when you do that, you get 4.63. Oops. As your answer. So that's how we work with fractional exponents or rational exponents. So hopefully you have a better understanding now of what to do. The key here is what we learned about at the beginning of the lesson, and that's if we have a fractional exponent, to break it apart into the root followed by the power, and with doing that you should be good to go. So good luck on your assignment.